Hello and welcome back to Element of Code. This is day 2, dive. So let's get stuck in. It says, now you need to figure out how to pilot this thing. It seems like the submarine can take a series of commands like forward 1, down 2 or up 3. Forward X increases the horizontal position by X units. Down X increases the depth by X units, and up X decreases the depth by X units. Now that since you're on a submarine, down and up affect your depth, and so they have the opposite result of what you might expect. Down increases depth, okay? The submarine seems to already have a planned course, your puzzle input. You should probably figure out where it's going. So basically it gives us a series of instructions, a bit like good old turtle robot. Your horizontal position and depth both start at 0. The steps above would then modify them as follows. Forward 5 adds 5 to your horizontal position, down adds 5 to your depth. Okay, so it's just moving us on an XY coordinate plane. It's just sort of the Y axis is inverted. Calculate the horizontal position of depth of you would have after following the planned course. What do you get if you multiply your final horizontal position by your final depth? So let's have a look at our puzzle input. Okay. So I'm copying that. Let's come back to here. Okay. Let's see. We want to create a new file. We'll call this input day2.txt, and we'll paste that. Again, this has 1000. So we now need to read these. So right now our read input is reading a file line by line, but then converting each one to integer. But now that we've actually got text, this kind of needs to be different. So it's going to be bool read day2 input. Again, it takes a file name, and then it's going to return an instruction. And this is going to be our orders, right? So we're going to have to create this now. This is going to be our instruction. And it's going to have a it's actually going to have a direction and a quantity or distance. So we're going to open our file. I'm going to fopen file name for reading. If file 0, we're going to do the usual printf could not open file. Actually, I'm going to do could not open file and pass in the file name. Return false. Do the same for the old one as well. Otherwise, remember to close it and return true. So our char line max line length, we're going to have to change this now because I think we had it set as 8, but now it can be a bit longer. I'm just going to bump it up to 32. That should cover all our cases, more than enough. Read day 2 inputs, char line max line length, and then we'll do our while f gets line max line length final so we're actually going to have an array of strings, and this goes down to what? Up to 1,000 instructions. Lines count equals 0, and so we'll do lines count plus plus equals line. And then we need to pass this into input. And the way we can do this is there is an alternate way we could actually do this to fgets. For example, we could use fscanf. Let me open the documentation for fscanf, which lets us sort of pass in, it reads a formatted input, so I can sort of, you know how I can print f and use those format specifiers for a string, I can almost do the inverse operation of that. So let me just comment these out. So I could do f scanf file, it will be %s %i, new line, and then that would go to our line, and then if we were to print f, we could do the direction is line and distance %s and distance equals %i, and we would give it line and distance. So comment selection is semicolon holding control. There we go. So this would be read day 2 input. We'll pass it input day2.text. We're just going to pass out a null pointer for now because we're not actually using that. Let's see if this compiles. It does not, because we haven't got our enum direction yet. Enum direction, which is going to be forward, up, down. Does it ever use backwards? I guess because it's a submarine, it can never go backwards. Interesting. So this takes in instruct, instruction. Oh, I misspelled that. Oh, I guess this doesn't have null pointer, so we'll just pass in 0. And let's run this. AOC has stopped working. Let me just get rid of this for now, so we don't use it. So what's not working here? Just make sure this is actually being read. Successfully read file. So it is being read. It looks like our fscanf. If we have a look at this, it takes in the. Let me just get rid of this for now, and then to read an integer. Is actually %d, not %i. Decimal integer. Okay. So the is actually slightly different. So yeah, %d it wants. So let's check this. It really doesn't like that. I guess because, let me change this to a char star. So this is going to be called the direction. I'm obviously not using this function correctly. Oh, of course, it needs a pointer to the integer. No. Oh, and then this has to be direction. Oh yeah. Oh, distance to. Oh, I need to put a new line here. Let me build that again. So here we go. It's read the first instruction, which is forward 2, direction forward, distance 2, successfully read file. So if I copy paste this now, and we did it twice. But we also tell it to read the new line. It should then read down 2, forward 2, and then the next one should be forward 6. All right, so that's working. So we just need to put this into a loop. So while file does not equal end of file, we'll do this. This can go. I've forgotten how you check for end of file in a good old, let's do C file, end of file. If F I guess this would return right. So I would do this. Well, that does not equal 0. Here we go. So if we go all the way down to the bottom, I think that is stuck in a loop. So just a sec, I'm gonna have to tell it to stop running AOC. Oh yeah. Got this build panel. I think I actually want to do this. F end of file. Well, not end of file, something like that maybe. There we go. So if we look at the last 3 instructions, it says forward 2, up 1, forward 5. Forward 2, up 1, forward 5. So that's doing that correctly. So this will take our list of instruction, call this the orders, so we can actually get rid of these now. So we have we'll call this the current order. So this would take the let me do this. So what we want to do is if string compare direction is forward, so we're going to do like a series of else ifs. So we have our enum direction so this is actually our direction string. I'm going to get rid of our print line. Then our dir equals forward, else if stir compare direction stir up. Our dir is equal to up, else if string compare direction stir down. Our dir is equal 2 down. Let me get rid of this. So then we also want our order count is equal to 0, and then our orders order count dot direction is equal to our direction. Our orders order count dot distance is equal to distance, and then we increment our order count. So our struct instruction orders, we know there's 1,000 of them, and then we pass in orders. Let's see if that even compiles. I think we need to include string.h for those string compare functions. Instruction. That's now done that. It successfully runs. So now we just need to validate, once we've read the input, that those are right. So what I'm going to do is just say for equals 0, we'll just read the first 10 instructions. So we'll say struct instruction order equals orders I. And then we'll do printf. For now, I'll just print the distance, which is going to be the order.distance as a new line. Let's just go back to the top. So we should do that. AudiX. So if I do this, it's 2268882, 226888278. So yeah, so that looks good. We could do like a switch, right, on order.dir, like case forward. I would do forward. Let me just copy paste this. Case up. Oops. Up and down. I'll make sure of that. I'm missing a thing there. There we go. 22688, 22688, but our instructions are wrong. Forward, up, down. Or ups or forwards. Or down. Or forwards. Or forwards or ups. Just a second. Let me do print f order.dir. See, it's 1 0. This should be 0 1 and 2. So I'm obviously using string compare wrong. If I come down here to str compare, a value, oh, we actually want to check if the return value of string compare equals 0, because it actually checks equality between strings. So you could have 0, -1 or +1. And so I want to do equals 0, equals 0, equals 0 like that. I could even do an extra statement here where I do like print f unknown token right. I mean, it probably won't happen, but just in case. And then if I just get rid of that and we do this, compile, there we go, forward, down, forward, forward, down, forward, down, forward, forward, down. Cool, so now we just need our sort of our horizontal position, which is going to be 0, our depth, which is equal to 0. So on forward our horizontal increments by 1. If we go up, our depth reduces, and if we go down, our depth increases. But we actually want to increase it by our order.distance, not just by 1. So this would be minus equals order.distance and increment it by order.distance. And then our int result is just equal to the horizontal times the depth as per what it said. Let me just validate that. What do you get if you multiply your final horizontal position by your final depth? And then we'll just print that out. So that's going to be horizontal times depth is equal to percentage d, which is going to be our results. So compile that. Horizontal times depth equals 527. Hopefully, let's validate that. Not the right answer. So what am I doing wrong? Well, depth increases. Oh, again, I'm only doing this 1,000 times. So I'm going to do define day 2 max orders equals 1,000. Right. So anytime I use this, day 2 max orders, day 2 max orders, we'll compile this, run it. Yeah, that's a much bigger answer. What's that? I'm going to copy paste that. That's 1,427,868. So I'm going to have to wait a little bit longer. Let's see if that lets me do it. Yay! That's the right answer. So let's continue to part 2. Part 2. Based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is actually slightly more complicated. In addition to horizontal position and depth, you'll also need to track a third value, aim, which also starts at 0. The commands also mean something entirely different than you first thought. Down increases your aim by X units, down increases, up decreases your aim, forward does 2 things. It increases your horizontal position by X units, and it increases your depth by your aim multiplied by X. Right. I see. So like it's sort of simulating how as you go down you're gonna like tilt the submarine, and then when you go forward it's gonna push you, increase your depth even more. Again, note that since you're on a submarine, down and up do the opposite of what you make sense. Down means aiming in the positive direction. Forward 5 adds 5 to your horizontal position, a total of 5. Because your aim is 0, your depth does not change. Down adds 5 to your aim, resulting in a value of 5. Forward 8 adds 8. Because your aim is 5, your depth increases 8 times 5. Okay, so what I'm going to do now is create a new struct called submarine state, and this is going to have our horizontal, our depth, and our aim. And I'm actually going to have 3 functions now called submarine forward, submarine down, and submarine up. And these will also take in the submarine state. And it's going to take in the state as a pointer. So right now it's just the state horizontal plus equals distance, state depth plus equals distance, actually because they refer to it as x in I'm just going to call it x here. And then state depth minus equals x. And then if we come down to here, we're going to create our struct submarine state, and then the state dot depth is equal to 0, and state dot horizontal is equal to 0, and the state dot aim is equal to 0. To begin with. Alright. And then this basically becomes submarine forward. We're going to pass in a pointer to the state and the order. I'm going to call it in the order. Change this to x just for consistency. So that means when we're reading the input, our order equals x here, which means this now distance, this just becomes x at x. Very good, very good. Submarine up takes the state and the order x. And submarine down takes the state and the order x. So this just becomes state horizontal and state depth. So this should still give us the exact same result as last time. But now we can, within our forward, down and up logic, we can apply this. So let's just go back and confirm. So down increases your aim, up decreases aim. So that means our state.aim also goes up by x, and our state.aim goes down by x. And then this actually becomes state.aim times x. Let me just confirm that. Oh no, our state horizontal is still by x, but it also now modifies our depth by our state aim times x. Okay, and then the final, after following these two instructions, you would have a horizontal position. What do you get if you multiply final horizontal position by font? So that stays the same. Okay, let's compile it, run it. We get this huge number here. What even is that? That's what, 1,569,566,610. That's not the right answer. Your answer is too high. So what am I doing wrong? Because it says down increases the aim. Down increases the aim and depth. So if I comment this out, we should get that old answer. So what is wrong with this? Depth, aim times x. Increases the depth, increases your aim, decreases your aim. Down 5 adds 5 to your aim. Forward 8. Because your aim is 5, so it's 8 times current aim. Up decreases your aim. I'm actually confused where I'm going wrong here. Our depth. Let's, to debug this, let's just look at the first four instructions. So we should have, in fact, let me not do it in here, let me do it in R Scratch. So forward 2, so we have our horizontal, our depth on our aim, which will start at 0, 0, 0. So forward 2 should increase our horizontal to 2, down 2 should increase our depth to 2 and our aim to 2. Forward 6 would do that to 8, but then we do 6 times 8, which is 12, so it should increase our depth to 14. And then forward 8 should set our horizontal to 16, plus 8 times 2, 16, 16, 32, so our depth would be 14 plus 32, which is 42, 46, which means our result should be 16 times 46. If I get the calculator, that's 16 times 46, 736. So if I only do the first 4 orders, you can see that, hang on, let me print F. Actually, for each one, I'm going to print the current state. So I'm going to do H is equal to percentage D, D is equal to percentage D, and A is percentage D, and that's going to be state.horizontal, state.depth, and state.aim. So let's run this. And let's go back to our Scratch. So, forward 2, let's just validate this. So forward 2 should set H to 2, which is what it's got here, 2. Down 2 should set aim and depth to 2. So we've got 2, 2, 2. Forward 6 should add 2, 6, so we get 8. But also we should get 6 times 2, 12, so that becomes 14. And then forward 8. Should add that, so that should become 16. 8 times 2 is 16. And 14 plus 16 equals 30. So actually it should be 16 times 30, which is correct. 480. So my logic is actually correct. I must have misinterpreted something here. Let me just make sure I've got the right puzzle input. I think I do. By doing that, that's doing all sorts. Quite possibly I'm getting a if I'm up to the billions, I'm getting like a integer overflow. Make that an unsigned int. Let me just double check that answer is not correct. My answer is too high. I'm really stuck on this one. What's like the max signed int? The max signed integer value is I mean it's 2 billion. It's over 2 billion. And that was, you know, 1 billion. Less than 2 billion. fact that our aim never goes below. Our aim never goes negative. Let's do this again. So this is the first 10. And let me just do this in Scratch. So forward 2, down 2, forward 6, 2 plus 6 equals 8, 2 times 6 equals 12, plus 2 is 14, forward 8, that makes you 16, 8 times 2 equals 16, 14 plus 16 equals 30, so 1632, down 8, so that should now be 38, 2 plus 8, 10. Yeah, like the logic seems completely fine. Up 2, that should reduce this to 36, which it does. It should aim to 8. Forward 7, so that should be 16 plus 7, 4, 3, yeah, 23, that's right. And then the depth should be 7 times 8. 7 times 8, which is 56, plus 36 is 92. So what am I getting wrong? What do you get if you multiply your final horizontal position by your final depth? Forward 2 adds 2 to a total of 15. Because your aim is 10, your depth increases by a total of 60. Alright, let me do this smaller example. So this is tell you what, I'll create a new one. No, a new one called example day 2.txt. So this has forward 5, down 5, forward 8, up 3, down 8 and forward 2. It has 6 lines. So the max order is at 6, and we're going to input example day 2, right? So I'm just going to run through the example. Put you here. Can you see that all right? So forward 5 adds 5 to your horizontal position to a total of 5. Correct. Down 5 adds 5 to your aim. resulting in a value of... I know what I'm doing wrong. Down and up don't increase. They only change your aim. That's what you get for not reading. I bet you now if I run that, yeah, 900. So change this back to 1000. Change this to my normal puzzle input and run it. Go to the bottom. Here we go. It's still an equally large number, but it is at least, I mean, it's close. Surprisingly close, actually, since I've changed that. And let's submit my answer. That is the right answer. Okay. So that was the problem. When I was doing my, obviously in part 1 of this puzzle, we changed the depth, but not for this. You only change the aim. I think, yeah, when I was thinking in the morning, for oh, this is simulating that as you get lower, it also changes your aim at the same time. It was just a silly assumption I made, but really, like, going down and up is just pitching down and pitching up. Right. So I'm gonna get rid of this debug stuff. And then this is basically, I kind of want to keep my functions going, where I've got like void day 2 part 1 and void day 2 part 2. And this would actually, it would be cool if I don't think you can have nested functions in C. Yeah, in which case tell you what, I'll copy all of these. So you've got submarine forward part 2. And these are submarine forward part 1. So that becomes just that. That's just depth. These should be above. These I'm gonna again put at the top of this file. This should be day 1 max values. I'm just doing a bit of refactoring here. So our day 1, so here's this, struct instructions, wait, no, I want to take you, and do day 1, day 2, part 1. I'm just going to pass in orders. Day 2, part 2. And then if we go up to part 1, part 2, part 2, part 2, and this is part 1. I'm going to do day 2, part 1. Day 2, part 2. Day 1, part 2. This is day 1, part 1. So this is going to create our struct instruction orders. Yeah. Read day 2 input. This should be read day 1 input. I'm going to move this function down below car. And then if I compile that, this becomes day 1 max values. We've got some errors somewhere. Oh, because these need to be above where I use them. They need to be here. And there we go, day 1 part 1, day 1 part 2, day 2 part 1, day 2 part 2. So that's all a bit tidy now. Cool. So I'll join you maybe for day 3. I probably won't be doing a video for every single day, I just won't have time for that. But you know, I'll try and do as much as I can. Cool. See ya.